last time or this week we started to design bolted connection, and we talked about type of connection, what are the mode of failures, and something about bearing strengths. Hey, I cannot check of bearing until you can design of connection. What you mean? Yeah, I taught check of bearing, check of tearing first. Then I taught how to figure out how many bolts you need. That's right? But in your actual design, you need first to calculate how many bolts. I need first what is your connection first. Before doing any check of bearing or tearing or anything, how many bolts do you have? What are the arrangement of your bolts? So the first step in your design of connection, first step at all, design of member. Design of member. Maybe tension member, maybe compression member, go ahead and design your member. Then, first step in design of your connection, how many bolts you need. So you need to first to figure out what is the design strength of one bolt based on what is the type of your bolt, what is the diameter of your bolt. Then you can figure out what is the design strength, shear strength of one bolt. Based on the force in your member, tension or compression, divide this force by design strength of one bolt, you can figure out how many bolts do you need. How can I arrange these numbers of bolts? Go ahead and maintain the edge distance, maintain the distance between center line to center line, then go ahead and put your bolts. Maybe 2 rows, maybe 1 row, maybe staggered. But if your arrangement is 1 row or staggered, maybe your number can be odd number. But if your arrangement is 2 rows, your arrangement must be even number. Because I cannot add something like this. Actually you can, but not efficient. Okay? One more thing. In a check of bearing or tearing, this term for tearing, if you use this value, you are checking of tearing this area or this part of the connection. If you use this value, you are checking of bearing. If you use the smallest value, you are checking of one of them and you are safe of the other one. So we have 2 values. We will use the smallest one. We are going to use the smallest one to check of one of them and to be safe for the other one. I have a question. We have here a term called T. What is the T value? What's T? Thickness. For what?
Smallest part.
Remember, we have 2 parts connected together. Maybe gusset plate with member, maybe plate or angle or channel or whatever. So we have at this connection, we have 2 thickness. Maybe thickness for your gusset plate and another thickness for the member. That's right? Which thickness? Smallest one. We are using the smallest one. Smallest thickness. Also, just for your information, it will not required in the exam or in the problem, in the homework, but just for your information, what will happen if your bearing or tearing are unsafe? What should I do? Nothing. Go back to your equation. How can I increase this value? How can I increase this value? That's all. If your bearing or tearing are unsafe, means this value or this value are smallest than or smaller than P ultimate. Because your design philosophy, P ultimate must be smaller than or equal anything here. So what will happen if this value, not smaller, is greater than this one or this one? What should I do to make it safe?
Increase the thickness.
Yeah, go back to your equation. Actually, 1.2, I cannot do anything. If ultimate type of steel, maybe I have limitation to change the type of steel for the structure. Maybe you can increase LC or T. What is the value of LC? LC is the edge distance between the face of your bolt or your hole to the edge of your member. Actually, I can increase this value a little bit. 1 inch, I can increase it to be 2 inch. Also, I can increase thickness. 1/4 inch, maybe a half inch, maybe 3/4, maybe 5/8. So I can increase thickness, I can increase LC to increase strength against tearing. For bearing, we have another option. Besides increasing thickness, you can increase something else. What is? Diameter of your bolt. Yeah, if you have here very thin bolt, I think bearing will be critical. If you have larger size of your bolt, I think your bearing will be good. So maybe your bearing or tearing are unsafe. So what is the factors I can change to make them safe? Thickness, LC for tearing, or thickness and diameter of your bolt for bearing. Okay, so the second type of connection, which is welding connection. Very simple. Welding, very easy. But we have disadvantage. Do you know what is the disadvantage for welding connection?
Awesome.
If you would like to refabricate your structure, you need to release this welding. I think you will make more damage in your member to cut all this stuff. But if your connection is bolted connection, it's very easy. Just release the nuts of the bolts and that's all. So anyway, structure welding is a process. We have the connected parts can be heated and you can add molten metal added to the joint. We have additional material at this location between the connected members. We have two types of welding, fillet weld and groove weld. Groove weld means if you have steel plate like this and another steel plate, go ahead and make groove in between both of them. This groove will be filled with molten material. So you need first to add or to make groove in their connected members. But fillet weld, just you have right angle or you have angle between two connected members. Like if you have steel plate this direction and another steel plate in this direction, in between you can make your welding between the two angles. So we will focus on fillet welds. You have two connected member making an angle maybe 90, so we can make weld in between without any preparing any groove or anything. Just to let you know, we have something here called welding size. Welding size for fillet weld means what is the distance in this direction or this direction, because both of them are equal. For your welding looks like a triangle. If I asked you what is the size of your welding, you mean what is this distance or what is this distance of your weld. This is called welding size, W. We have another thing called L. What is the welding length? From this point to this point called welding length. So we have two parameters. First parameter, size of your weld. Second parameter, what is the length of your weld. If you go back, hey, for this welding, from here to here, this distance called L, welding length. If you can zoom in for this welding looks like triangle between this angle and this gusset plate. This triangle has two lengths which are equals, W and W. W is the welding size. So for any weld connection, we have two parameters, length and size. Your size is very, very small. So W is the weld size, L is the weld length. If you would like to get the nominal or critical shearing stress for your weld, you can divide your load in your member divided by 0.707 WL. According to LRFD or AISC, your nominal strength of any welding size equal 0.707 W L F NW. If you add factor phi to this nominal strength and phi for welded connection equal 0.75 for fillet weld connection, 0.75. So phi Rn will be design strength of welded connection. W is the weld size. L, weld length. What about FNW? What do you think? FNW. FNW, the strength of the electrode which is using to make your welding. Did you see welding process before?
Yeah.
We have a rod which called electrode. This electrode or this rod has a material with tensile or ultimate tensile strength, maybe varied between 60, 70, 80, 90 until 120 psi. So your ultimate shear stress FNW for this material that used in welding equal 0.6 F the ultimate tensile strength for this material. So after you are done with your weld, the shear strength for this material after welding equal 0.6 times ultimate tensile strength of the material that used in welding. So finally, your Rn equal 0.707 W L F N W. This value of F N W equal 0.6 times F E X X. This value of F E X X according to what is the type of your rod you are using to make weld. Maybe FEXX equals 60 or 70 or 80 based on what is the type of rod. So once you get your Rn, go ahead and multiply it by Phi Rn and Phi for fillet weld equal 0.75. Then I can tell you what is the design strength of your weld. Also, your B ultimate in your member must be smaller than or equal Phi Rn of your welded connection.
What material is being used that has a like big tensile strength of like 120?
120 KSI, it's called high strength steel.
Is it steel?
Yeah, high strength, but if you decrease percentage of carbon in steel, you will get harder and the high strength steel but low ductility. If you remember, we have stress strain here for steel. The normal steel, the common normal steel, something like this. Sometimes, maybe this steel has a percentage of carbon, something around 1% or 0.8%. But if you reduce this percentage, you can get something like this. But less ductile steel or brittle steel, like cast iron or something like this. So brittle steel, as you see here, once you get your maximum, suddenly you can find fracture. But for this one, no, at yielding, no, we can see some